right, arithmetic sequences. We are in our patterns and sequences note packet, and we're on page 9, which talks about arithmetic sequences. So let's fill in these blanks. An arithmetic sequence is a series of numbers where there is a common difference between consecutive terms. That means you always add or subtract the same value to reach the next term. The graph of an arithmetic sequence is linear. In other words, it'll follow a straight line when we graph it. Okay, we're going to find the common difference for each of these arithmetic sequences. So what it says is there's a common difference between consecutive terms. Difference means subtract. So if we take 5 and we subtract 2, that gives us 3. So what I did was I took one term and I subtracted the previous term. Now I'm going to take the next term, which is 8, and subtract the previous term before that, which was 5. And that gives me a common difference of 3. Now I'm going to do 11, subtract the previous term of 8, and that gives me a common difference of 3. Did I get the same number each time? Yeah, so the common difference, we're going to call it D for common difference, is 3. And that's because 2 plus 3 is 5, and 5 plus 3 is 8, and 8 plus 3 is 11. So what would the next number be? 14 would be the next number, right? And it would keep going up from there. Okay, let's look at question 2. So what are we adding to 8 to get a negative 2? We can find that answer by subtracting. Negative 2 subtract 8. What is negative 2 minus 8? Perfect, negative 10. Then the next number would be negative 12 subtract and negative 2. Well, taking negative 12 and subtracting a negative 2 is the same thing as adding 2. So negative 12 plus 2 would again be another negative 10. Negative 22 subtract negative 12 is the same thing as negative 22 plus 12, which is also negative 10. What's our common difference? Negative 10. So it's adding a negative 10 each time, or subtracting 10 each time. So what would the next number be in our sequence? Negative 32, and then negative 42, and then negative 52, etc. Correct? I'm going to move. Oh, that's not what I meant to do. They're not cooperating with me. Move this whole thing over. Perfect. Okay. So let's do you want to try the next one by yourselves? Right, hopefully you had a chance to do number 3 on your own. I'm going to go ahead and go through it with you. So I'm going to take 25 and subtract 32. And that gives me negative 7. 18 subtract 25 is negative 7. 11 subtract 18 is negative 7. So each time if I take the next number and subtract the previous number, I get a negative 7. So that's our common difference. So a negative 7 is adding each time. So that would mean that our next number would be 11 minus 7, which is perfect, 4. And then 4 minus 7, which would be -3, etc. So have we seen a lot of patterns that fit these descriptions? When we've been doing patterns and sequences, have we seen patterns that are created by this, like this, by adding the same number or subtracting the same number each time? Yes, we have. We just didn't talk about them being called arithmetic sequences. We didn't talk about the common difference being called the common difference. We just used that to describe the pattern. I'm not going to take a lot of time on this part because we've run out of time this semester to do this unit, really. So this is just some information about what's known as an explicit formula and a recursive formula that will help you work with arithmetic sequences, but we are going to skip it for our purposes just because we are going to quickly get through this. If you want to know a little bit more about the explicit formula, I'll go ahead and tell you. A sub n is the nth term, which refers to any term of the sequence. So the nth term of the sequence would be any term you want to talk about in the sequence. A sub 1 is the first term. I guess the nth term, it could also be the last term. Sometimes when we work with these, that's actually going to be the last term. N is the term number. And then D is the common difference. So if you are personally interested in learning more math and want to look through these examples to find about arithmetic sequences, you can, but we are going to skip this. We just basically learned the basics of what an arithmetic sequence is, and I don't know, let's do this problem right here. This is pretty easy. This gives us a formula for an arithmetic sequence, and it says find a sub 17. Do you guys know what that means? That means that n equals 17, and we plug it in. To find the 17th term. I didn't speak and write the right thing at the same time. Plug it in to find the 17th term. So like if you have a sequence, it would be the 17th number in the sequence is the 17th term, right? So this formula is going to help us do that. So all we do is 22 subtract 8 times 17. What that's going to do is subtract 8 17 times because -8 is the common difference. So 22 minus 8 times 17, I'm using a calculator. And because I'm subtracting 8 over and over and over 17 times, I'm getting a negative number. So my answer, my 17th term, from subtracting 8 and then subtracting 8 and then subtracting 8 and then subtracting 8 till we get to the 17th number is -114. Hopefully that makes sense. We're not going to worry about the example right above that because I'm just kind of doing a crash course on this stuff. All right, stopping this video, and we'll do a new one for geometry.